Hey guys, we're going to take a look at some of the math involved here with the physics of electrostatics. Remember, I had a charged sphere that I charged up in the classroom, and I charged it with additional electrons, and then I put it near, and then I touched the sphere onto the second sphere. Well, we're going to call the first sphere particle 1. We'll call the second one particle 2. So particle 1, we're going to say, has a charge or a Q value of 8 microcoulombs. It's just a it's a number to represent the charge of an object. Let's say the charge on the second one was a positive 6 microcoulombs, and then the radius in between was 1 meter. Okay, we want to feel that attractive force between the objects. So the objects, first of all, they're going to be pulled towards each other, because they're negatively, there's a negative and a more positive. So the attractive force can be said to be a negative number. Okay, and then to find the force, the electrical force between the two objects, it's as simple as taking our K value times the charge 1, charge 2, and then radius squared. Now notice how familiar that looks to gravity. Except gravity uses masses instead of charges. And gravity also uses this gravitational constant, which was a tiny number. Okay, tiny number. And this here is a very large number. Okay, the difference is humongous between 6.67 to the negative 11th and then 9 times 10 to the 9th. That's a big difference, but the formula is the same. Okay, so if we wanted to find the force exerted between these two objects, all we would do is use our K value, 9 times 10 to the 9th. Now we're going to get into some crazy exponents here. The Q value, the first one, is negative 8 times 10 to negative 6th, that's micro, and then times 6 times 10 to the negative 6th, all over 1 squared. Okay, so let's do the calculations there. Okay, so after doing the math here, okay, what I ended up with was the electrical force of 0.43 newtons. So these guys feel an electrical force of about 0.43 newtons attractive to each other. And that's pretty impressive, actually, because the size of the object has nothing to do with it. And that's how to calculate the electrical force between two objects. Now, in the next video, we're going to get into a little bit of more of a difficult situation, and we're going to try and add in gravity into this whole situation. Okay, good luck on the questions.